Hello guys, what's up? And my name is Present Songamika and welcome to my channel Can Present Code. Let's find out. Okay, so every day I learn from my computer, okay? I go to Google and I learn something new, okay? I go to Facebook, I see a website, okay? I see a link to a website, I click on it, I read and I learn something from it, okay? I'm learning from my computer, okay? So in a way you can say that my computer is teaching me stuff every day, okay? That thing might be useful or might not be useful, mostly not useful, okay? But today I've decided to do something opposite. Today I've decided to teach my computer, okay? You must be wondering, how can I teach my computer, okay? That is impossible, okay? You might not think that is impossible if you know about the term that I'm going to say soon. Anyway, we will be learning about machine learning, okay? I'm going to show you from the scratch, okay? And by the way, if you don't know anything about the computer programming, Python programming, basic programming, don't worry, you won't understand anything, okay? That's disclaimer. First of all, the first thing I'm going to tell you guys to do is to download this dataset. We will be doing iris dataset, okay. Now what is iris dataset? Okay, so iris dataset is actually let me see if there's anything here. Okay, so iris dataset is a flower actually, okay, and there are four species, okay: Setosa, versicolor, virginica, and there's supposed to be a fourth one, but I cannot find it. Okay, for our dataset we have only three types, okay: Setosa, versicolor, and virginica. Okay, sorry for my pronunciation, I'm not good with pronunciation, sorry for that. Okay, so first of all, let's create a file. For this tutorial we will say it's machine learning that by, okay, I'm going to teach my machine something, okay? So first of all, let me start this up, then okay, let me zoom in here. First of all, let's make a virtual environment and let me call it let me just call it machine learning. No, that doesn't. ML, let me call it ML. That's good, okay? Wait for it. And there we go. This is my new virtual environment where I'm going to think of this environment as a bag, okay? I always like to think this as a bag, okay? And I'm just gonna put stuff in here. First of all, what I need is uh, let's install pandas, okay? So panda is one of the Python library, okay? It is actually pretty cool and it will help us to read this CSV file, okay? Okay, now guys, we have successfully installed machine learning, okay? I'm sorry, we have successfully installed pandas. Now I'm going to show you how you can read the data, okay? Wait a second, let me just switch to ML. Let me refresh, and there you go, ML. Import pandas as p, okay? Okay, now let me just make a variable, okay? Let's say it's data, okay? and let me say p dot read csp, and the name of location. Okay, so for us it's dataset slash this file. Okay, now if I print this data, I should get, okay, as you can see here we have 149 data. Okay, and this is sepal length, sepal width, petal length, petal width, and species. Okay, this is the CSV file that we have just imported into our Python, and we have printed it out using Python. Okay, that is cool. Okay, so now what are we going to do? Look at this mess. This is actually really messy. Okay, just look at this. It is not user friendly. Okay, and it is very uncomfortable to look at. Okay, let me fix that for you. Now what are we going to do is, let me zoom in, pip install matplotlib, and it will not take a lot of time, and done. Okay, now what can we do is, we can import matplotlib dot pyplot as pt. We can do that. Okay, could not be resolved from, don't worry, it's just I need to rerun this, and don't worry, it will go away. uh, don't mind that, ignore this error for now. Okay, now what I can do is print this data. Okay, so I can say, oh, what we can do is say pt dot, first of all let's say data dot petal length. Let me do this and do this and say, okay, let me just say this is equals to a value, let's say for now x. Okay, and let's say for y equals to data dot width. Okay, so if I say pt dot scatter x comma y, and then if I do this, if I run this code, okay, it seems we do not have petal length data frame. Oh, sorry, my bad, I forgot a z here. Okay, so let me run this code again, and as you can see here we have some graph here. Okay, this is actually very nice and comfortable to look at. Okay, now we are going to learn a bit more about this graph. Okay, this is a very important step in machine learning. Okay, this is very important in teaching your computer how to predict which flower is it based on the value you have given. Okay, before I do that, let me just install C1. Okay, okay guys, so we have successfully installed C1. Now I'm going to show you how cool C1 is. Okay, so I'm just gonna import C1 as sp. So just wait a second. Now what can we do is, now previously we needed to like access data petal length column. This petal length is a column name, okay, and this petal width is also column name. Previously we needed to access that, okay, to plot, basically plot, right? Now I'm going to show you something cool, okay? Just look at this, okay? So I'm going to say SP, and wait, it's faced grid, okay, and I will pass in the data. This data is the data from here, okay, and I'm going to say hue equals to sorry, species. The species basically what we are trying to say with this hue species is that plot different color for different species, okay, and we're gonna say height equals to 5 for now, okay, and we're gonna say forward slash sorry forward slash and say and then what are we going to do is we're gonna say map is a function, okay, map is a Python function. What are we going to do? Sorry, it's a method. It will take in a function that is p scatter, it will take in p scatter, and we need to assign petal length comma petal width, okay, and I'm gonna add legend. Okay, I forgot comma here, okay, sorry, I forgot this. Now if I run this code, as you can see here, it looks pretty cool. Like, look at this. This is Setusa, this is Parsi color. It's Parsi color, right? Yeah, Parsi color, and it's Virginica, as you can see here. Sorry for my pronunciation, by the way. I'm very bad at pronouncing, okay. Lately my pronunciation been all over the place. It's so bad, I don't know why. You can see it's much better and much comfortable to look at look at it right now than previously. Then previously it was like this data. Previously it was just data. There was nothing graphical about it. It was just column, and there were data and rows, okay. There was nothing in it, nothing beautiful to or comforting. But this data, you can get a lot of meaning from this, okay. You can say that this species Setusa, most when you plot its petal width and petal length, it will fall under here. So there must be a reason why, there must be a formula, there must be a pattern, okay. There must be some way to determine if it's Setusa or this Virginica or versicolor based on its input value, okay. So this is first of in machine learning, the first step is to understand the data, okay, is to visualize the data, okay, and this is the first step we are taking, okay. Let me just do this. Okay, run Python file. Okay, now this is one of the way to visualize it, okay. We are not going to do that. I'm going to show you another way where you can visualize, okay. That is actually pretty cool. You can do pair plot. Yeah, it's pair plot. It will take a data comma, and hue, it is going to be a species, and it is going to take height, which I'm going to assign 5. No, I think 5 will be too big. Okay, height 3. So if I run this code, as you can see here, it looks really cool and really beautiful. Okay, this data, you can get lot of information from this data. Okay. Okay, if you cannot see what's down there, wait a second, it's a bit buggy. You cannot see the bottom index, the horizontal one. Okay, but this is sepal length, this is sepal width, this is petal length, and this is petal width. Okay, so this is how you can visualize the data. Okay, now the visualization ends here. Okay, now we are going to code. Okay, let's code now. Let's teach our data, I mean our computer, it can differentiate between the different species. Okay. Okay, now what are we going to do is we are going to take some data from our data. Okay, because our data is our data. Okay, our data is our data. Yeah. Now what we are going to do is we are going to use a built-in function, and that built-in function is ilock. Okay, so we're gonna say data dot ilock. Okay, ilock, and we're gonna say column, and we're gonna say -1. So what does this mean? Okay, it is very important to understand what does it mean. It means that take every column, take all of the column, okay, except for this one. And it doesn't just take the column, it also takes the row value. Okay, for example, if I had like 1 here, okay, if I had just say 1 here and printed x, let's comment this out. Okay, so it will go to 0 column and 1 column, it will scan, right, and it will say see this 1 column, right, and it will take this whole row. Okay, so it doesn't just take this column, it will go to this column and select whole of this row. Okay, let's see what happens here. Okay, it will print out this 4.9, 3.0, and that. Okay, so as you can see here, it's printed 4.9, 3.0, 1.4, so it printed out the 1. Okay, but we do not need that. What we need to do is we need to take everything except for this. Okay, we need to select from 0 to last. Okay, and we don't need this one. Okay, so what are we going to do is we are going to say this, and if I save this, okay, and if I run this code again, as you can see here, we do not have the species column here. Okay, we have successfully splitted the data, we have successfully done that. Okay, now we need that let's call this capital X, because that is, I think, international convention or something, I don't know, but let's call it that. Okay, say ilock. What we need here is everything, just the negative one. Okay, Okay, if I print y here, it will give me species name. Okay, you can see here the our y now contains species name. Okay, now we have successfully done the first step. Now let's go to next step. Okay, for this we need sklearn. Okay, so we need to install another module. What is this? Let me just say this. So we need sklearn. Okay, to install sklearn, we can say pip install scikit learn. Okay, so we have successfully installed sklearn. Okay, so there is a really cool library from sklearn. Sklearn is mostly used for machine learning, I think. So what do we need to do is we need to import sklearn. Okay, not let's import from sklearn model selection, import train test split. Okay, this is actually really cool. It does like half of the job for us. Okay, so there's a like a ratio, you need like 80 to 20 to test and split. Okay, you train 80% of the data and test on the 20% data, or I think it's other way around. You train 20% of the data and you test on 18%. Okay, so train test split, what we are going to do is we are going to say x train comma x test comma y train comma y test is going to be train test split x comma y. It is going to accept this too, and it is going to say test size, we are going to say 0.2, that means 80% to 20%. Okay, the size is going to be 20%. Okay, we are going to test 20% of the data and we are going to train 80% of the data. Okay, so test size this, and let's say random state equals to 0. Okay, now this is splitting data for training and testing. Okay, now we are going to use logistic regression. Okay, first of all, what we need to do is we need to import logistic regression. Let's just import bunch of stuff from sklearn. The things that we are going to need, the first thing that we are going to need is logistic regression. Okay, and logistic regression is in linear model. Okay, from there we can import our logistic regression, and from sklearn.matrix we can import confusion, I think it was confusion matrix. Yeah, it was confusion matrix. Yeah, from sklearn import. We also need accuracy score. Okay, the accuracy score is going to tell how accurate our data, our prediction model is, and we also need classification report, which is also going to be imported from sklearn matrix. So classification report, we need bunch of this. Okay, So let's go to logistic regression. Now what are we going to say is, let's say, classifier. You're gonna say logistic regression. Okay, this is going to be logistic regression, so that we do not have to call logistic regression every time. Okay, and we are going to use fit method. Okay, that fit, we're going to say x train comma y train. Okay, so it will take some time to load. So you must be wondering, what have we done here? Okay, what is logistic regression, what is this classifier fit doing? Okay, so basically think of this. First of all, you need to know about the data types. Okay, there are categorical data types and ordinal data types and other data types as well, but right now I'm going to talk about categorical data type. Okay, so there, let's say there are colors. Okay, red, yellow, blue and white. Okay, let's say there is yes and no. Okay, there are two columns. Okay, now when somebody says red, okay, you cannot measure it with red. Sorry, when someone say yes, you cannot measure it with yes or no. It doesn't give a measurement value. Okay, those type of data are called categorical data. Okay, and in those data type we use logistic regression. Okay, where the two different data cannot be measured. Okay, for example, if somebody says the car is going 28 kilometer per hour. Okay, 28 kilometer per hour, and someone says let's say someone says someone is wearing a red shirt. Okay, you cannot measure the speed with the red shirt. Okay, they are categorical. Okay, um, they can be related if they show a pattern. Okay, if a car goes 28 kilometer per hour and there is a frequent appearance of a guy or girl with a red shirt, and if we can collect those data, we can maybe predict that how often this red shirt person comes. Okay, but basically you get the idea, right? Basically it means that uh, it means the two data types cannot be measured. In such case, right now in our X train we have the data, we have the petal length, we have petal width, with that sepal length, we have sepal width. Okay, and in our Y train we have species name. These two data cannot be measured. Okay, so we use this classifier fit. Okay, for a basic linear regression we can use y equals to mx plus c. Okay, in y equals mx plus c, it draws a line, right, to it will try to draw a line to predict the path. Okay, it will try to contain those points within this line. But in this logistic regression, there is not always a line. Okay, it can be a curve. Okay, it will draw a curve that will try to encompass to fit this line. Okay, the fit is trying, what is it is trying to do is it will take this X train and this Y train. Okay, and it will try to come up with the equation equals to Y train equals to weight dot X train dot bias plus bias. It will fade it will try to fit the weight and bias accordingly, and it will try to come up with equation. Okay, it will try to come up with a region. Okay, with a sense, some sense of okay, and it will try to, based on that model, it will predict the future data. Okay, So this might be a little bit complicated, okay. I also only know, I also don't claim that I know everything. I'm also a beginner, okay. I'm also learning about this. Okay, if I learn more about this, I will keep on updating you, okay. Basically, let's just say how have understood is this fit will create a equation, okay, based on this and this, okay. This will take two variable and try to create an equation. This x train is not just one value, but as you can see, it's lots of value in it, and y train also has lots of species name in it, okay. So we are going to say classifier that fit, okay. Now let's create a predict. Now let's predict, okay. We have already trained our model. Now let's predict. We will just call y predict, okay, because we need why have we call y predict is because y contains our species name, right? So we use y predict, so it is more readable that way, okay. Now we are just going to say classifier fire dot wait a second, y predict. Predict is a function. Now what are we going to pass? What we are going to pass in here is we are going to pass in test, because we need to test, okay. See, so if you notice, it was gray and later it became blue. That is the X test loading all the data contained in it, okay. Now we have predicted. Now we can just say print classification report y predict sorry, not y predict, y test, comma y predict. If you see here, it will say y true and y predict, okay. This y test is the data that we have slated, okay. We have splitted y into y test and y train. We use y train to train this model, and we are using y test to see. We tested a model, we made a model, and we use it to predict the model, okay. We predicted some value, okay. Based on this model, it will find the equation, okay. It will find a equation, and then when we from this line, the x test, it will put in the value of x test, and based on this model, it will generate a prediction, okay. And what are we doing here is just basically comparing this y test with y predict this, okay. We can also say print confusion matrix y test y predict, okay. And also we can say, we can see accuracy score, okay. This is also the same syntax, it also takes same parameter, that is y test and y predict, okay. Now if we run this code, okay, okay, so this data just a second, I will okay. So you can see here optimize result precision etc 1, okay. This means our precision is 100%, okay. 100%, it has predicted with this one, means that it is 100% accurate, okay. This is actually really good. I don't know why, I think I use a different data earlier because I was not getting this 100%. I got around 0.9, but right now I'm getting this. It's actually really good. Previously I think I got around mm, 0.93 or 0.9. This is so this can predict which species is it based on the input data 100%. Okay, this one means that this accuracy score. So this is for today. Thank you so much for watching my video, and I will see you in next video. Thank you. And if I have made any mistake, please let me know. I'm still learning. And bye bye.